In this problem, we're going to construct a confidence interval suitable for testing a claim. We already have the hypothesis test completed. We have the null and alternative hypotheses here, which tell us that this is a right tail test because the alternative hypothesis was that mu1 is greater than mu2. And the significance level was 0.05. So when we do a confidence interval for a hypothesis test, what we're going to do is look at what type of test it is. And we said that was a right tail test. So I have that 0.05 on the right-hand side of my distribution. Because confidence intervals are centered, we need to balance this out with 0.05 on the left-hand side. So here this is 0.05. So the two tails together make 10%, and that means that we have 90% in the center. So I look at this problem. It's a test about two means, and the samples are independent. So we're going to do a two-sample t interval. And we're going to put in the statistics that were given with the problem. So you have x bar 1, S1, not yet, and N1, X bar 2, S2, and N2, and for this problem, let's see, X bar 1 was 97.81. The standard deviation was 0.93, and the sample size was 11. And for the women, the mean was 97.25. Standard deviation was 0.72. And N2 is 59. Okay. So we've got our sample information here, and now we just need to say what the confidence level is, and that's the 90% that we got above. And so once you put that into the calculator, you're going to get a confidence interval that is negative 0.166 to 0.888. So does the confidence interval support the conclusion found with the hypothesis test? Well, this interval contains the value 0. So that's what we're looking for. Does it contain the value 0? And it does. And so that means that we would fail to reject the null hypothesis. So whenever you have 0 there in the center of your confidence interval, you fail to reject the null hypothesis. So that's how you do that problem.